All right. So thanks for showing up to the Control Conference in this talk. My name, as mentioned, is Mike Elissen. I work as a solutions engineer at Akamai Technologies. It's a name that doesn't ring a bell for a lot of people, but actually you're using Akamai on a daily basis. And I'll tell a little bit more what Akamai does, but instead of just talking about what Akamai does, let's first get settled in what is going to happen during this talk. So just a short agenda for the next 20-30 minutes, of course. We're going to talk about the loading screens and why gamers abandon games and what happens when you have to download large files, which is a problem that happens quite a lot nowadays with both desktop and handheld games, PC games. You have to download large installs. And we're going to tell a little bit more how that works, how the internet is powered at the bottom line, what powers that, what drives that, and how you can solve that by using a content delivery network like Akamai or some of our other companies out there who specialize in that. And then in the fourth part, we're going to talk a little bit how you can protect your assets, your games, your servers from attacks, and how, again, companies like ourselves help out there. So let's get started over there. So first of all, what do gamers expect? I mean, this should be a good baseline for everybody attending this session. A study was recently done which showed that about 80% of the players that download games or play games experience slow downloads. They experience lag, disconnects, which we've all experienced. I mean, we've all been playing games, and everybody has run into the situation where a connection drops, you get thrown out of your multiplayer match, or you try to download a game, or you buy a brand new system, and you have to spend hours to download a big day one update. It can be frustrating, and the study has shown that over 40% of those people actually decide to churn from your game. That basically means they leave, they abandon, they play another game, and especially when you guys have working extremely hard on developing fantastic games that are being enjoyed by people, games that are being driven by microtransactions, games that are being driven by, from a free-to-play aspect, and try to get more revenue to that. It can be very frustrating that these people just up and leave because of these disconnections or slow downloads. And that's why, again, we have Akamai to help out there. So again, part of the study as well is obviously load screens have a negative impact on gamers' perception. Again, it's just something that happens all the time. Whether it's a scrolling bar, a rotating bar, or just a static screen that says loading, it is having a negative impact on the gamers itself. So what we've seen is, especially when you look at mobile games, smartphone users expect things to load under 2 seconds time nowadays, where maybe in the early 2000s things were like between 4 to 6 seconds. Now we're actually looking at instantaneous. It needs to be there. When you boot up the app on your iPhone or on your Android, it needs to load instantaneously. Otherwise people get frustrated, and that delay that is created is just a frustrating thing. Now, and again, with millions of games nowadays available in the App Store or even on systems on PC, again, it's very easy to just pick up and play a different game in the same genre. Lots of competitors out there who make equally as interesting games, and they hop around quite easily. So by focusing on this problem and trying to solve that in a clear-cut way, you can actually lead that your gamers stay sticky to your game, and that you actually solve this problem. So again, why are there loading screens? I mean, this should come to no surprise. I mean, load screens obviously are there to when you're actually loading data from a disk, cartridge. Who remembers the PlayStation 1 era where the disk is spinning and it takes 45 seconds for a level to load, or processing time on an actual device. But most of the time nowadays, loading screens occur because you have to download content for the game. And content can be pretty much everything. We are looking here at the initial game install. So when you're actually downloading it from the App Store, that you have to install that. And Apple, and Android out there, they have a set requirement of about 100, 150 megabytes that you can download in your initial install. And sometimes that's not enough, so you have to add in game updates. What about DLC, patches for your games, and just game data in general, images, video files. Those who are developing with Unity, you have Unity ads, and also the ads from Unity have to be loaded into your game. And that is all that content takes place, whether you're playing your PC game, your console game, or you're playing a mobile game. And again, that's just something that has to happen. It has to be retrieved somewhere, and I will show you guys how that actually works. So let's talk a little bit and move on with demystifying the actual internet. I mean, internet, the cloud, it's a word out there, but not common to everybody how it actually is powered. So again, talking about this content delivery, so how does it work? So on the one side, you have your server. This can be in a data center somewhere. This can be your own locally hosted server somewhere, or as more commonly nowadays, using a cloud hosting provider like Azure, Amazon Web Services, where you have your content. Your game install is there, your patches are being there, they're available for download. But again, how do you distribute that, and how do you get that available out there to all the people out there in the world, which are, again, millions and millions of people playing games on PlayStation, Microsoft Xbox, Nintendo devices, Steam, or even Android and Apple again. Millions of people out there, and also these users out there are usually not very close towards this server that you're talking to. You could have a server right here in the Netherlands, whereas your gamers are downloading things all the way from Brazil or all the way from Australia. And even though the internet is rapidly fast, that usually takes a lot of time to get that data there. So what is happening there? Obviously, you have the internet, which is nothing more than a collection of servers and networks, a collection of networks. And you use underlying internet protocols like DNS, IP, internet protocol to actually get that data. You look up where the content is loading, for instance, on your PS4. A request is made from a certain area or location where you can actually pick this up. And that is then being retrieved from this server and then being returned back to the user. And that basically takes time. Requests take milliseconds, but it adds up, especially when you're talking about 100 megabytes, gigabytes even. That just takes time, and we've all experienced that. So to show that a little bit more in detail, what we have here is a waterfall graph. And how that actually works is, first of all, you have might be a little bit difficult to see, but in the bars, first is this DNS protocol. It's the domain name service where you actually need to look up where you actually can find these resources. And that takes several milliseconds. After that, what happens is you establish a connection between the gamer and the actual server that's out there. That's usually done nowadays HTTP or HTTPS, where you do encryption, and it takes some time to trust each other and connect this data with each other. Again, that adds on some milliseconds as well. Then you get the first content out there, and then from there on out, it just starts downloading the content. Connection needs to be reset after certain timeouts, etc. And again, this all adds up. And if you look at it at the big graph, this is a traditional waterfall graph for a web request, for a website. You load all these different assets. And again, if you have one big, large install, it will only be one bar. But if you're talking about maybe 50 or 100 images that you have to load because you have a Facebook game and it loads all these different little images and PNG files to actually make that happen, you end up with a big graph like that. And these protocols that the internet is based on have all been written back in the 80s and 90s, where at those time it was only futuristic to think that billions of people would be connected to each other. And those protocols on its own, they have some issues with them. So again, you're looking here at a concept that's called backend time, where you have to actually retrieve it from the server. And then you have this situation that's called the middle mile. It has to traverse over the internet. And then you also have the time that is spent on the device, on your desktop or on your system to actually get that loaded and processed. So that being said, that kind of gives you a basis on the Internet 101. That's how the internet works. That is quite straightforward. You can go in depth. I can stand here and talk a little bit more in depth how the actual protocols work, but there's only limited time. So If you have any questions, we have a table set up downstairs, and I'm happy to delve more in detail. But let's move a little bit on in regards to what Akamai does, our Akamai Intelligent Platform, as well as certain other great companies out there that do the same thing. So Akamai is one of the original conceptual ideas about content delivery networks. We have this huge platform, which is about 240,000 servers worldwide. And we actually started as a university, the university in Massachusetts, in Boston, where students developed these smart algorithms. They already realized that with the internet growing back in the 90s, those protocols were not smart enough to be able to handle all that traffic. So they wrote these smart algorithms to be able to deliver content in a smart way and develop this concept called caching. And basically the term content delivery network was founded. Nowadays, Akamai has grown, and we work with some of the largest companies in the world, but also with smaller companies, startup companies as well, to help them deliver their content, their game content, but also video content, websites, web application, and we really handle about 15 to 25% of all daily internet traffic on a daily basis. Our platform is, of course, has to be secure. We're working with banks as well. You know, your credit card transactions that you're using on the Sony PlayStation Store that are being processed over our platform as well. So we have to make sure that it's secure, it's reliable, and that it's always available. So again, this is how we started back at MIT almost 20 years now. So why do these companies choose to go with Akamai? And that's basically has to do with the infrastructure versus delivery. So what you can do to solve this scale problem is by just buying a lot of servers or talking to server companies out there and just keep piling on servers and replicate your content out there. But that's usually not the smartest way to actually solve the situation. What you can actually better do is use a content delivery network that helps you distribute that content out there much faster. So I'll show you again how that works. So again, we have this server there where you upload your original content. You just put that there, or maybe even two if you want to have primary and backup situation. But again, you have your users. So what actually happens is, if you look at the cloud again, but actually transfer that in the Akamai Intelligent Platform, so these are our 240,000 servers, what happens is all the people from, say, the Netherlands or from Amsterdam, they're actually connected to a server in Amsterdam. People from in Brazil, they are connected to a server in Rio de Janeiro, for instance, and that is basically how that works. Then what happens is we route that traffic over our own platform. Usually what happens is normally they use a protocol called the Border Gateway Protocol, or BGP, and it's all these large internet service providers. They all compete for each other for traffic and bandwidth. And the routing there is not really done in the most efficient and effective way, which causes a lot of delay and latency. And again, if you're talking about a multiplayer game, multiplayer session that is reliant on fast and quick, low latency, then that is not the most efficient. So that's where, again, Akamai comes into play, where we can route that in a smart way with these algorithms and make it faster. But then also what we do is we cache the content. So we actually take your patch, your update file, your 100 megabyte file, and we'll actually store that as close as possible. So this is, for instance, how, say, a Nintendo is able to launch their new Switch update, or how Sony is able to release their newest 4.6 version for the PS4, is by already making sure that that content is available worldwide, and that players from Amsterdam and players from Rio de Janeiro can download it easily, download it fast, and make sure that it's actually available. So that's the concept of caching, and that you can only do that with files that are shared across all the people. That's the same type of download. It's the same type of patch, same type of game data bundle. One thing, of course, that you also have is actually content that you can't cache. It's personal data, it's login information, it's multiplayer packets that have to be traversed over the internet as well. And again, that's also where Akamai comes into play. We actually help out by connecting these gamers, whether they're normal desktop or console gamers or mobile gamers, connect them to one of our servers close by, and then actually we handle all that smart routing all the way towards your game servers or your data centers in the cloud that are actually powering things like matchmaking, chat, or actually just sending the packets across from technologies like TCP and UDP that you can see here. So that, again, gives you a little bit of a basis about what Akamai does. This is only one part of it. This is only the web performance part and the delivery part. Over the last couple of years, though, as you may have heard in the news or actually experienced yourself, is the rise of attacks. We have had a huge increase, as you can see here on this chart, as what we call distributed denial of service attacks, DDoS attacks, where huge amounts of servers or infected computers or even Internet of Things like IP cameras, etc., are actually infected and then used to target a server or a host or website out there. And that has grown nowadays, where we saw last year with an attack over a terabit per second. And usually that means, if you think about this at your home network, you maybe have like a 50 or 100 gigabit line. This is easily able to flood your entire infrastructure. If you have a small set of servers out there, you might not be able to handle this scale. And again, what happens if this large attack tries to swamp you, it will go down. It will be unavailable. We've all, I'm sure, have experienced this or seen it in the news where an online banking application is no longer available because it is under DDoS attack. We've seen it a couple of years ago where Sony actually was subject to this large attack. Hackers tried to take it down and they actually succeeded, and they were down for quite a while, which was pretty horrible to them. A lot of reputation damage, which hopefully they are now obviously recovered from with the success of the PS4, but this is a serious issue out there. I work with a lot of gaming companies in Europe myself. I've seen it a couple of weeks ago where one of the games, they were trying to launch a free-to-play version of their game, but they were attacked or they suffered a data center outage, and all of a sudden nobody could play anymore. So they worked for many, many months on creating their game, or actually their free-to-play version of their game, and then all of a sudden it's unavailable. Led to a lot of reputation damage, complaints on Twitter, and now again nowadays with so much different competitive games out there, they just move on to the other game, or they go back to a different game that they're already playing. And it's really an inherent problem, and again, companies like Akamai can help out there. Now, to put that into perspective, we actually do this State of the Internet report because we see so much traffic. I mean, we're talking about trillions of requests on our platform on a daily basis. And we actually see that gaming companies, the gaming industry, game developers, game publishers, they're the ones that get attacked the most. Gamers, they're tech savvy, they're smart, they know their way around the internet, they know their way around, launching tools or even simple tools that you can download online to start DDoSing something out there. And it happens on a daily basis. And we see that a lot within gaming, and it's a serious, serious problem that we are facing right now. And again, being able to be up is important. So how this actually works is, again, you have a hacker out there. And what he actually tries to do is, try to launch an attack towards your website. Try to get through the website and try to attack the server by that and putting it down like that. Other option that they have is actually attacking something called an API. Mobile apps nowadays, they don't require you to go to, or even the games, they don't require you to go to a website. It uses this API, which is just a code-based way of delivering and retrieving the content. And again, they can do attacks like that as well. They can find out your IP address or actually try to take down what's called your DNS. Because if you take that down, nobody is actually able to retrieve the content anymore, because the DNS kind of works like a phone book. Where can I find PlayStation.com? Well, you can find it on this IP address. And if you take that down, then nobody is able to resolve that anymore. That happens quite a lot as well. And then obviously, as I talked about, you have these botnets where they just use these affected machines over and over to try and take down any of these points, whether it's DNS, whether it's the website, whether it's an API or a form or anything out there. They try to take that down, and by doing so, people won't be able to play the game. Now, and again, what happens here is, again, companies nowadays out there are trying to focus on this, and Akamai is one of them, one of the more successful out there who is able to help companies. And again, we are doing this for a lot of great gaming companies out there nowadays, whether they're large enterprises or small enterprises, but protecting them from this. So again, what happens is we basically route that traffic. So say PlayStation Store, it is connected to the Akamai platform. It is tying into our servers first, and we're actually able to protect them. We see and spot that this is a malicious attack from looking into the actual request. We can see that they're trying to do a specific attack, or they're trying to use something that is not legitimate HTTP or HTTPS requests. And then we can actually just block that and say, well, you're not allowed access to this. We can do this on the API level as well, where we can block that as well. And we have actually already seen with the big rise now, APIs is a big new attack factor where they actually find out these API endpoints, try to take those down. Because basically, if I take the API down, nobody else will be able to play the game, because you cannot do anything like matchmaking. You cannot do anything like logging in, for instance, and it's a huge risk out there. And then obviously we can help protecting by hiding things like the DNS. We can hide things where your original server is. And by showing it that is pointing to us first, and we can help you protect your what we call origin, your own servers. And then we have a huge platform. Again, those 250,000 servers that are handling out this data all the way over there in the world, they're also able to just deflect these huge attacks. And again, where I've seen in the companies that I work with struggle with handling, say, a 50 or 100 gigabit per second attack, Akamai is able to deflect over the 20 or 30 terabits per second of attacks. And luckily, those haven't been launched yet. But botnets and so many more connected devices. I mean, how many devices do you have in your house that are powered by the internet that you can log in now? They can easily be infected. They are not the most secure devices out there, and they can be turned into a malicious situation. And that's what's happening nowadays as well. So that's basically giving you a baseline, one-on-one on how DDoS works, how security works, and how attacks are being launched and what you can do to prevent that. Again, very important. Now, in the end, just as a summary, what does this actually mean, what you can achieve? I've been highlighting some of the companies out there already. Nintendo is one of the companies that we've been working with for many, many years now, out of Akamai in Japan. But they are actually able to scale, again, these worldwide releases of their updates and games. I mean, the Switch has now been sold, I believe, 10, 15 million units out there. They have to release their patches, their firmware updates out there, and they're actually able to distribute that through us. So that's why they work with a company like Akamai to be able to do that. They can focus on their expertise, which is developing great games, and then we can focus on actually delivering and protecting that. Now, a company out of the US, Big Fish Games, they actually did a study on this, and when they actually moved over their traffic over to Akamai and helped them out with downloads, it actually led to about a 40% global increase. This means that over the whole world, all of a sudden downloads were about 40% faster, and in certain situations actually even more. You have to think like hard to reach areas like Africa again, and South America and Australia, which do not have great internet connectivity. You can even look up to 100 or 200% increase. And then finally, in Germany, we have Aria Games, and they actually showed that when 2 years ago, when they went over to Akamai, it actually led to them having an increase of 70% better download completion rates for PC games. People all of a sudden stopped abandoning the downloads, or just because the connection timed out because it just took too long. They all of a sudden had a much higher increase, which obviously also led to installs, which leads to games, which leads to people buying microtransactions and generating revenue for your games that you're building so much time and effort into releasing those out there. Again, that's some of the things that Akamai can help you with. Whether you're a large company like Nintendo or whether you're an up-and-coming startup indie developer, we are definitely able to help you out there and help you point you in the right direction to be able to help you focus on developing your game but make sure that when you're actually launching it and when your game is ready to ship, even with multiplayer, that it's actually available by the gamers and they can actually enjoy it. And I've already talked to several people out there today, downstairs, and show them like, hey, this is can be a serious issue that when you launch, that your game actually struggles with that. So that being said, internet, it's easier than you think. I mean, yes, it does work on a lot of different underlying protocols. Although I've always ambitious, I do not know how to develop games, but I'm sure for you guys it's easy. And the same for the internet. I mean, there's many different people out there and companies out there that can help you with these problems about connectivity, about delivering content, about making sure that things run smooth or delivered fast, and that your games run fast. So hopefully you walk away after this session knowing a little bit more about the internet, gaining a nice trophy there, knowing a little bit more about what Akamai or content delivery networks do. Didn't really want to design this just purely based on Akamai. There's many other great companies that do the same thing. Just know how these type of companies can help you solve these situations. And know how to protect yourself, what happens when an attack is launched, how that works on different layers, and how you can protect yourself. So that being said, that's the end of my session. We also, if you're interested, you can go to www.akamai.com/gaming. There are some more reference studies out there, some great videos that we did. We interviewed several other companies out there and let them answer why this situation is important to them. Feel free to take a look there. And of course, I will be downstairs as well at one of the tables. I can answer any more of your delivery or security questions more in depth, myself and some of my colleagues that are out there. I believe there's a couple of minutes as well for some questions here if that's necessary. And otherwise, if you have some more in-depth ones, I'm more than happy to answer them downstairs. Thanks a lot.
Thank you.
Thank you.